Okay, so we do this step. Then from there, what do? We just give it the output, B1 spec, then click OK. Now it is there. If you look inside the folder, if you just go back, B1, you can see there this B1 spec. If you right click, open it with Word, edit in Notepad, you see the data. So this is the data of the spectral analysis for block 1. But we want to plot it inside the OS montage. We'll go back to map, and display spectrum. Then you see, we'll locate where it is B1 spec. They will now click OK. So now this is what we have. So you have your spectral block 1. Okay. So this is your spectral block 1, which you can see. Then from there, I think we have to look very well and see what we are going to do. Now this is the block 1. So we can do the same thing for B2. Utilities, reproject grids. I will select it, B2. B2LL is the one. So it is already in that format. They'll already in geographic. They'll call it B2XY. That's what we have. Finish. They are now projected this. Let's go back. Okay, now it's there. Then finish. So now we're going to work on this. We'll remove this B2. And now go to map. One-step filtering, prepare gate. Then this time we'll look for right B2 XY. Then we'll now name this B2. Start. We have done the map. Word filters. Now you see it as pick B2, then click OK. Go to map again. Spectrum display radial this. Now you can see, you can check. The name is B2. Then now change it to B2 spec. And finally, go out there, then look at display spectrum. This B2 we have created before. Now this is what we have. Okay. Now let me zoom to map. So let me use this one first, and try to see what we have. If you look at this one, actually, let me start with this one, how to get now, what you want to get. So this is a spectral analysis. If you go, you can see the slope is minus, the depth is minus slope over 4 pi, then it will be in kilometers. This is the depth from 0 to 2, which you can see. You see the highest depth, it reaches up to 2, just like what we saw the other time. The IRS, you see, is around 1 kilometer and something, which is in line with what we have done under the Euler deconvolution. Now you see, right from this part, I want you to look very well. Right from this part, you see this point? Look at this point. Down to this point, this is a noise. This because it looks almost, because the noise is at the lower depth. This is depth. This is the wave number, which is like almost the distance. From this edge, if you go up, you see that from this side downward, this actually is the noise. Then this portion here to this edge is the residual part. That is this portion you are seeing. Then from this edge to this edge is actually the deeper features. So this is the deeper feature. This line, which is this, is not even needed. What is needed, you have to look at this. This noise is how the noise appears. It looks almost the same at the lower depth. This sharp fall is a residual. From this point to this point, that is this edge. Is that so you are going to draw a line like this. For regional, you draw the next line like this. For what? For the regional is this. Then for the residual is this part. So that's how you are going to have it drawn this way. Then this one will go this way because they have different slope. That is the way to go about. Then if we go the other one, no, let me go the other one, not this one. Let's go to the other map, B1 specs. You see, B1 spec again is the same idea. You see, from this point on where this one start to fall, this part that you see is actually the residual. Then this portion to the left is actually the noise. So these are actually the noise. So if you want to take the regional air, this part you don't consider this. You start from this point, just similar to the other one you did. So this one, you can take it this way. Then that of the residual, you can now take it this way if you want. Because this is what you have. You see there is a noise coming around the side. You see right from this point where it starts, look almost the same. So this is actually the noise portion of this part. You see why it's not chip break. So this will actually give you the residual, and this will give you the deeper sources. So and that is what you need to try to figure out, that this is the deeper, this is the shallower. And from all these downs are actually the noise part, and that's why you see. Because you see this part are corresponding. I want you to look down here very well before we start getting the slope. Because you know everything about slope is changing Y, changing vertical over change in horizontal. You see, if you look at here, you see the value changes. If I put my mouse on this is the coordinate. You see, the first value is 0, almost 0. And the other one is minus 10. You can see it here. If I come here, the same thing. This is minus 5, plus 5. So you see the same scale. You see the same scale? So you are looking at this to know where the receiver. So from this edge to this edge, this is the noise. From this portion, because you see, I look at this here because it's just like a wave. It goes up, come complete. So this point, this portion is actually the regional. This portion to this portion is actually what? Our residual. We now have our residual from it. So that is how it looks like. So this portion, this is a break, which is at this point. To this portion is what we have our regional. So you see, so this is what we have. Now, how do we draw those lines? First of all, how do you draw those lines? You have to click on, go to this map mode, click on this. So you see, it's not here, you have to double click. You double click, this one will show. Now there is a line here. Draw a straight line. Click on this. It has changed. Now, this is where you are going to draw it. You draw it like this. So you let it go. So that is the first one. Then for the residual, that is between this portion and this, look at it, between this portion and this portion, this is the residual. This is the noise that look almost the same throughout at the lower depth. So we need to have something like this. So you see, so this is what we have as our this thing, as our this. Then if you want to edit it, and click on this, then click on this. Then right click, edit vertices. Now you can move it around and position it. So like so. So this is what you have. Something like so. So you right click again. Then you say end group editing. So these are the lines. So we need to get the first one. Now, so this is how we do it for the first one. If you want to do for the second one, the same thing you will do. But if you like, you can still look at this point and this. So this point is what you draw your distance to touch at this point. You click on this, double click on it, then click on this line. Then this point is our regional. You let it go. Then this point, you see it? So you let it go. So you are looking at this portion, and this portion, this is the residual, this is the regional aspect. All these are noise coming this way. Then now, how do we get the slope? Let's start with this one. How do you get the slope? Now, if we want to, this, we have to now edit the colors. I'll give this one red. I'll click on it, right click, attribute. Change the color here to red. Okay. This, you can give it 6 and click OK. I see I've changed it to red. Click the other one, right click, attribute. So I hope you're not getting it, right? Hello?
Yeah.
Okay, so now that's what you get. You change this color, you give it blue, okay. Then you increase the thickness to 6.6, then okay, then you have this. Now this is what you have. Then you can now put text on it. Double click. Now there's a text. You can write. You can now say deeper sources. In this case, the slope is equals to maybe minus 0.00 something, which they will call font properties. Change color to red, and okay. If you like, you can increase it to 3. Then okay. Now you can see it here. Cancel. Then you click on this. Can move it here. That's the deeper one. So we'll now take the second one. Double click, then add text for the shallow one. Shallow sources slope is equals to minus, because it's going to be minus this. The line is coming down. Then here is 3. The color now is blue. Then okay. Click on this. Move it where you want it. Okay, no, okay. Okay. Double click on it. On properties. We'll set it to bold. Properties, you can change the font size here to bold. So now, how do we get the what? Our slope. right? How do we get our slope? Here is going to simple. I want you to look very well. There are two scales here. This scale is different from the other scale. If you look at, let me double click. If you see, you have something here. This is ruler. Click on this. You see ruler. It's coming out. So all these are rulers. You can off it here. Then you can have this is to auto snap to grid. This one is just like a grid line. You can zoom. Let me zoom out a little bit. You can see it. These are all grids. You see, I want you to look down here.
Yes.
The values to change. If I bring it at this minus, you see it's my, you see,
Yes. Change.
the value is different. You see the value?
Yes.
The value is different. You see, it's not actually the scale one. Remember, this is y. Y, x, you see 0, right? Then this y is minus 12. And that is what you need to take note of. Let me zoom out. Then now, after you select it, then you will able to right click. No, what to select it first? I'm sorry, not here. So this is what we have. We first select this cursor to. See, if we go to our cursor to, this is minus 10. Make sure this is what you selected. Then right click, you will see views. You see, we have the map, the data, and the base. The data is this one. You see it? If I move down here, this is 0. If I move here, this is 0, this, right? Then I can also measure the length from here to here to confirm from here to here to see the length. How you do it? You still right click. You see there's ruler. Remember, I want to find the slope. What is the slope? Change in vertical over this. Let's go to ruler first. If I click the ruler, I want you to look down here on my disk. Can you see it? Start the protractor. Do you see it? Hello?
Yes.
Are you see? So this part is what you're going to put at. If you just click, right click, make sure you select this one first. Right click, then you go to ruler. And I see it has changed. What the ruler does, I will click from here, right? Then come down to 10. So please, what do you see? 10 point something, right? It's around 10. Is that so?
Yes.
So this is
Yes.
how you measure, right? If you click, you see, if you now right click, you see it has able to get those value. See, so you have clicked, you will just cancel first. So that is the ruler. But if I want to measure from here to here, if I right click, let me check first. Ruler, I will click from this point down to this. If I click, so please, what is the answer there?
Two.
Let me cancel. Right click, views. Okay, I'm still in data. So if I now right click the ruler, then this point to this point, so do you see it now?
2 points.
Two point, right? If I come
Yes.
there, 1.5. Do you see it? If I come here, it's 1. Almost 1. If I come here, 0.5.
Yes.
Do you see it? So this is what the ruler is doing. You can cancel. If you
Right.
want to end it there, you see, so it has give you it. So that is the when you right click, you say cancel. Let me take it again. Ruler. Let me take from this point. But you see, it has snapped to the other point. And that is what you have. You see, so the answer is 0.74. You cancel it. So now, let's find the slope. Ruler, ruler. We take the red line, right? For the red line, we click on the point. You see, we're going to find the slope. What is the slope? Change in vertical. You click on this, come down to this point. Yeah. You see it?
Yes.
Now, what do you have at that point? You see, at that point, you have to get a piece of
Mark
paper.
outside.
You get a piece of paper and write it down. Don't move. Remember, vertical, it has to be vertical first, like this, vertical. But because remember, it's minus. It will be minus. No, I've moved it down. I'm going first. Let me cancel it. Let me remove this one, this snap. And let me zoom. And let me zoom now. So from there, we right click, ruler, come down to this point, right? So this point is minus 6.22298. That is change in y.
Yes.
Yeah, at that point, right? You cancel it. Oh, I'm sorry. Click ruler, this point, vertically straight. So you can go at any range you want it. Like this. You click, right? Then I go to the other point. You see, his point is changing. I want you to first look at it. When I right click, ruler, click, come there.
Okay.
You take the value first. 7.3266.
3266.
Then you now click, then you move to the other side
Okay.
till it touches the line horizontally. So what do you see? 0.1.
0.1431.
0.1432. 0.1432. 0.1432. There you click. So done. So now, so this is what you have. You see? So now, you see, you have drawn your line, right? You have drawn a ruler. If you bring your ruler here, so you see the values are down here. So it has measured this value for you. I'll give it. Then we'll go back to our Excel. Delta Y. Delta X. Delta Y is what? Minus 7.3236.
3266.
And the other one is 0.
0.14312.
0.14312. Yeah. So now that is delta X. Then how do you get our slope? Our slope is going to be
Delta Y delta X.
delta Y over delta X. That gives us this value, right?
Yes.
So this is the value we have. So under this value, we now say it's going to be equals to our depth. Now it's going to be equal to minus slope divide by open bracket 4 times pi. Pi, this is 4 times pi. Oh, what happened?
Your pi.
Mm. Oh, I've not given the value. Is D, right? Is D 4? So you see, so this is the value we have. We see we have that value. If we just come there to the grid and check this length that we have, this length to this length from here to here, So if you zoom out, so this is what we have. So we are able to find the slope is this divided by 4 pi. So, and that is what we have here. Divide by slope, divide by 4 pi. Theta y this. So this is how it is done for us to get the slope. If we want to do for the second one, ruler, you see we put at this. If we now click here, at this point, you can see it's around what? So the value is what? The value is around
8.8099.
8.8.
8.8099.
8.8099. Theta y. Then you click, it has gone. Then you move to the line horizontally. Like this, click on that line. 0.3 something, right?
Yeah,
So
39157.
delta x 0.39157. 0.39157. So this is what you have. Then you now click. Then you say done. So you have this one that is now remain. And from there you have to go back to your Excel and change value. Values 8 minus 8 8.8 8.8 099 then 0.39 157. So you see, so this is what we have, right? So you see, so this is what actually we are getting. So the depth is this. Remember, this one is in meter, right?
Yeah.
So this is in meter, and that's what we have. So in kilometer, divided by 1,000.
0.001.
So that is what you have here. Then if you go to the other part, what do you have for the other part? So the other part, so that is how you do the other part here. So this is how it is done, so that you can able to now get the something you have, the depth. What was our this one with the first one? The first one we did was what? So you see, the first one we did was around somewhere. Let's go back. So this was 1.79 we have. So the other we have is this. So I think that is how we're able to find the slope here. Using this one. If we change it to views base, so the base one is this one. So you see, if you look at this value down here, so if you look at this value down here, this is what you get. The value along the x is 8.5. Come on, this 0.5. No, it is not picking it. Let me see. Map. Okay. Okay, this was the one. Is 0.5. It's picking it. Here is around what? Because this is in the K unit, you have it. So this is around 0.3.
Yes.
Then this one is around what? 1 point. See the y coordinate here is this 1 point something. So that's 1 point something meters. So why this way? Because it is the depth is in K units. So it's in K units. So it's not in kilometers, it's in K units. So that's what we have. That is per wave number. So it's per wave number, and that is what we have. I know per wave number, that is see per 1/K unit. You know, K unit is per meter. So if you take the up of that, it become roughly in meters. So that is why we have to divide by this 4 pi. So that's what you normally have to do, because this one is not kilometer. It's not saying this kilometer. It's just trying to tell you that this is in the K unit. So that is what you have here. So you are able to find the depth for the what? Shallow ones, right? So the shallow ones, they are here. So this is what you have. Hmm. So now you can see them here. You see, so I think this was block one, right? That's all. This was block one. And because of this red, mostly this one, they're outcrop. That's why you see the basement. It may not really be that this is a basement. The more shallow area, which are very small. But as you go deep into the grid, maybe midway around when you come to this side, you start to go deeper and deeper. But yeah, these are mostly outcrop, right? These are rocks on the subsurface. And that's what normally you have sometimes, when you have the noise at that area, a lot of noise, you see. So that's why you see our grid one was this area that we caught. And that is the reason why we have that issue. Mm. So that is the reason why you see at the end of the day, our average, so it's going to be like that. So that is the issue that we have here. That mostly less this thing you have around that area. So I think that is. So this is the spectrum. So this is the SPI, and this is the okay. This one I'm not on this one. So it is the other one. So this is the other one that we done. So in this way, you can able to now go and not change the scale that you have. But if you go back to the desktop, where I save those sources, you can see this something like so. So you see the sharpness. You see how this one is go down. You see, it's not necessary you may have it the way you think you get, but this is what sometimes you get. You see this one, show sharp down. You see, the moment you see a curve like this, sharp down, it means that these are deeper sources. They are more deeper, you see. I was able to get almost to 4 kilometers. That is around what? 122 meters, which is a very high depth. You see, because the slope goes down. Take note, whenever you see or look at look at the shape of what you have. You see, it's not that much sharp down, right? That's why you see that issue is there. That's why I see the issue is like that. But this one you see here, right? I give you, it is once you go deep, maybe to another block, right? So this why this block one is not the one I did, but is the other one you see. How do I change that name? You come here, you go to this, double click on this, map mode, double click on this. You see, you click on it for what? For block one, that's all. So it has there. You can add, double click on this, you edit, you put a slope. So that is how it is done. This way. That's how you see I was able to edit this one, have something different. So this is how I got. You see the slope? So the slope here is this one.
Fine.
So this was minus 5.6 that I got, while the other one is around 1.8. Okay, so this is what I actually got. You see the shallow, you see the idea is that the shallow one are very small. That's why the deeper one have high slope.
Mm.
The widest one have small slope. So, and that is the idea. So that is why they are deeper. They have the sharp slope. This one, the up slope. That's what you see. Yeah. So this is what you see. If you just do it, then you can able to get those ones. So that is what we do. But then again, if you want to get the slope again without using the ruler, you can make use of your two coordinate system. Y1, Y2, X1, then what? X2. Then the slope. And if you want to use the ruler, the slope is going to be equals to y2 minus y1, then divide by, open bracket, x2 minus x1. So there's no value yet. Oh, I'm sorry. Is equals to the value of this y2 minus y1 divide by, open brackets, x2 minus what? X1. So this is what we have. Then you go back to this. Now you first cross check whether the value, this is 0. You bring the value here, this will be minus 10. This is correct. So you just bring your mouse on 2 point, just put a point, put your mark, and look on the scale. What do you have? You see the value you have at this point. I want you to look at. The first value is your x, this is y. So if you position it there on the map, on the line. So what do you have? You see, if you bring it, if I bring, you see, I bring at the center to confirm. You see, this one is almost 0, this one is 9. So take note. So if I bring it here,
0.07.
if I bring it here, what do you have?
0.07.
Then your x is 0.073 and y is 5.64664,
5.64.
something like so. Then this point 1.
0.059.
They come down to the next point here. The next point, this is line. You position it. That will give another point. What is that point? What is x now?
0.2027.
0.2027. Y is what?
2.
Minus, right? Minus 2.4016.
2.4016.
So the next point, this next point is your y2 and x2, right? Because you are going down. So this is what you are going to now enter here. When I come to my y1, that is the previous one, is 5.64. The y2 is minus 2.4016. X1, the previous one is 0.073. Then minus what? Okay, no. Then X2 is going to be 0.2027. Right, so this is what we have. Let's see the slope. Okay, I use the other one. Supposed to be D. This is D. Right? So I think this is what we have. You can see it, right? So you can see, so this is the value. We check. So this is what we have. D10 minus D9, this are this. So this is what we have. So from here, what is the depth? The depth is going to be equals to minus slope divided by open bracket 4 times pi, right? So this is what we have as in what? It's our meters. So just like the other one we have before, right? So this is what you're able to get. The same thing we do the other time before. So that's how we're able to do this one. So if you like now, you can export this one. You can go to map, export, and put to JPEG, then come to screen, change this one to 460, then okay. The images, Spectral block 1. So I think that is the thing. So I think that is what we have. I think that's what we have now. If we now go, so this is how to do the part of the spectrum for all those blocks. You can do for all those blocks, then you sit down, you tabulate. But remember, as you go deep down, once the slope becomes so high down, that means it is going to be very high, just like this.
Yes.
Once you have this shape, you know, oh, it's a deeper source. That's why you see up to this 0.4. And that is how it is being done. You see a lot of noises here is taking place. So, and that is, so what we have there, then we go to our images. We see it now, I've increased into high resolution. You can see it. So you can still go to it back and edit it and look at it. All you need to know, you look at this shape, from here to where all this one, they are noise. So right from this point onward, you don't draw line here. You look at this change. This is just a go up and come down. So this portion from here to here is this deeper. From this point to this point is a shallow. So this don't some people just come and start taking like this, which is wrong. They'll be taking that, okay, they will take at this, then they will take another one like this. Then why is the noise? So if you take your shallow like this, then why is the noise? It's supposed to be three part, the noise, and the other. That's why you have the shape, three different shape. Up this portion, then remain flat. It remain flat. This one gives you the true picture. It is a depth estimate. True picture from 0.5 up to downward is a noise. From this to the middle point, here you have the regional, there you have the residual. So that's how it is done. So I think it has been a wonderful training. We have come to the end, right?
Yes.
So now I think what remains for us is to take it further and now take the spectral further. Like I said, we have things we can take it further to now do geothermal, this, where we're going to work data with that data to do it more better, and this are able to do it as what we have. So what we have next is this one. So it's going to be a paid course. That is this. So So this is what actually I'm trying to plan to do by next week. Actually, so it's going to be a three-part. So it's going to be a three-part, actually. One is mapping geothermal energy potential using aeromagnetic data through spectral analysis. So then the two is 2D modeling of aromatic data using James Sims bias montage, and other producing geological and study area maps. So with this one, you're able to complete it. So it's going to be 4 days program. Then each day is going to be 3 hours. So it's going to be a comprehensive one. So I think by next week or so, I will let you know if you're interested
Yes.
in the something. So that is what we're going to do. It's going to be a kind of practical, a case study of what we have did, just to show you all the basics on how to draw map, you know how to export map, everything. So this will help you now to take it further, to produce those work that I show here.
Okay.
You can see, let me
So,
show you something that we're going to do. This is the first paper we're going to do because I have data. This one is not my work, but it's somebody work. But we'll do almost the same thing and now reference it and see the similarity, the findings. So, okay, this is my own. Let me see the other one, 2D modeling. You see, this is part of, I have the grid, so I've not shared this grid to you. Is during the training, we'll get those grid. We'll see exactly what is their finding. How do they come about this? How do they do all those contour and the rest, get the profiling, the conclusion? We'll now look at the conclusion, what is happening. Then this is my own part. It's a basement area. We'll do it towards the end and all how this map are all producing. Then lastly, geothermal energy potential, where you are going to explore that data of the spectra and go it further. You see, so this is all under, you see the spectra, how to come up with this. There are many blocks here. They do all this one, calculate this one, then use software and do, you see, this one is different from the other one, you see it? How this one come about, how the heat flow, and the rest we're going to do. So that's what we will try to do next week. So I expect you have a question.
so is
Yeah,
that 50 US?
yeah, it is 50 US. It's 50 US because
Okay.
it is resources intensive because those grade that I give you, they are not free. So even this
All
one I
right.
give you for the training, I give you to
Okay.
share. It's not so. End of what I will do, I will share this folder of all what we have done, the folder
So,
of our
yes.
training, so that you go over it
Yes.
and see what we have done. You
So,
got, yeah, yeah.
so when is the training?
So no, what I am to
Sometime
just
next
get
week?
into. By next week, I'll just play the advert. I think you have my number, right?
Yes,
Right?
I think so.
Okay, so you have your number so that you can just forward it to me. So once I post it, you are going to be notified, right? I'll
Okay.
post it there on
Yes.
my site and every other place for you so that in case it's online, you have to know. So this is my number. You get in touch with me so that I'll keep it
Yes.
because I don't want it to be crowded. At least even if it's 20 is enough because the more, the less is better because it's
Okay.
going to be, because the moment you know this one or these three, then you have dealt with magnetic to be able to look at other people work they have done,
Okay.
take part of that area and do analysis and see whether your findings is in agreement with what you have established your confidence. Geothermal, you look at geothermal, look for a places that have those flows, compare to other works, what is your finding? You have to do this. So you cannot use this modeling, this and this, able to achieve a lot. Because if you come to Oyas Monta, you see when you come to EULA, you see this one, is this located EULA,
Mm.
analytical peaks, there is P depth. All this one is also part of modeling. There is P depth. Look at P depth
Okay.
that they have not done. This is P depth. This one is also profile based. Is there. GIMSys is there. This is GIMSys.
Mm.
GIMSys, it is three because it's going to be actually a one main part first
Okay.
that to do because this GIMSys you see is modeling. It is trying to model G stands for gravity, M stands for magnetics, SYS stands for seismic data. It's used to model three things. You isolate an anomaly in an area. You get the magnetic data at that point, that location. You get the gravity, then you get the seismic, and measure the true picture of the area. So, and that is what is being done in mineral exploration. They combine all the three and model. But what we do here is mainly for the magnetic. The gravity will come later. That is gravity magnetic modeling. The model to that is more of the geological map. Then finally, if the data is available, they will now merge seismic. It become complete all at once. But mostly, if you have to finish you can model gravity alone. That is in order to come in agreement with the subsurface features. Or if I look for minerals, you can also use to now characterize those areas. So our focus will not only first be on the magnetic. Once you build out of magnetic, it will be easy to migrate to what? Gravity. So that's what you need to know first, how to go about the modeling aspect and do it better. And look at the place where you are doing this modeling. What information do you have? What is your target you want to achieve? So, and that is what we are going to see. So I don't know about the others ones. Do you have any question? Hello? Hello? Umar, I don't know whether Umar has a question.
No, thanks.
Okay,
I'm
okay, no,
traveling. I am
okay,
traveling.
okay, no problem, no problem. So this is what we have. So I've
Thanks.
upload all that video on my YouTube, the one we did before. This one also is going to be uploaded. So you can have like this. If you have any question, you can get in touch with me. So I think we can end it from here. See you next time. See you another time.
See you
At
next
least,
week. Thank
okay,
you.
next week, no problem.